for PIC microcontroller. To be precise, PIC 16F877A. Okay, so throughout this lecture, we're going to look at, for the initial part, we're going to look at some of the related programming languages, some of the history, and then from there, we're going to look at the flow of program coding, starting from high level to lower level, and then lastly going to the hardware part. And then we're going to go deeper for C programming. We're going to look at some of the basic part needed to program successfully C programming, the declaration, the data type, and then the condition, the case, and then the looping, and then that one, some of the sample program related to C programming. So right now we're going to look at general aspect, the fundamental aspect of microcontroller programming. So you can see here. We have series of several programming languages. So these programming languages is arranged, assembled in the form of pyramid. Okay. Looking at the top part, we have three examples of the available programming languages, starting from Fortran, C language, and then Pascal. So this group of program language we call high-level language. Okay. So what are you going to do? You're going to program C. Yeah. So C belongs to high-level language group. Okay. It also included other available such as Fortran, also Pascal. And then looking at the bottom, the middle, the part we have assembly language. So assembly language would be the original, the oldest. It is among the first high-level languages. Okay, so most widely used during the 80s and then the 90s, but still used today. Okay, but the popularity is not greater, not high compared to C, Pascal, and so on. Okay, and then looking down, we have machine language. Okay, so what is machine language? Machine language, we also call it as a machine code. So basically, machine code is a code that consists of a string of binary 0 and 1. Okay, so the code can be something like this. Okay, so the code is here. Okay, 1001, 001, and so on. Okay, this is binary language or machine code. Okay, so machine code. So machine code, the hardware, which is can be electronic devices, robotic, microprocessor, microcontroller, can understand and can communicate with machine languages. Okay, so you can see from here. Okay, this is gap. Okay, we are writing in the form of high level, and then the hardware can only understand low level, okay, which is machine code. So there should be some kind of bridge connection between high level and also machine code. So that one you will learn later. Okay. So why does the hardware can understand machine code? Because, for example, taking PIC 877A, it only have very limited instruction. So basically, if you refer to this diagram, okay, this code will be embedded inside the microcontroller, and then when microcontroller receive the first sentence or the first row of the code, that particular code will be compared with the 35 instruction. So it will match with one of the 35 programming instruction. So that's why it can only communicate. The hardware, the microcontroller can only understand machine code. Okay? So this is the example of C program. Okay? So this is not a complete part of the section of that particular C languages. So you can see here the transition starting from C and then go to binary. Okay? Before that, hex. Okay? Hex, and then 1 digit of this hex is 2 digit, 2 digit hexadecimal, is equivalent to 1 byte, 1 byte of binary data. So this one will be embedded into the microcontroller. So why do we use C language, high level? Because simple, simplicity on the programmer, on the developer, so not on the hardware. This is the flow. Okay. Every time you write, or the programmer, the developer write the program in C languages. Okay. So for example, taking our course as example, we use MPLAB IDE. So we write down the program using MPLAB IDE, and then we compile. Okay. The compiler is XC8. Okay. So what does the compiler do is that it will check this program for error. If no error is detected, it will transform these C languages. Okay. So to be precise, okay, first it will transform into assembly language. Okay. So if you don't know, this is assembly language. Okay. This is assembly language, and then once the assembly also being generated, it will continue generating hex file. Okay. So this hex file will be embedded, will be burned, embedded inside my controller using a programmer. Okay. So maybe on the second half, you're going to do this okay, physically. Okay. But for simulation, no programmer. Okay. Everything need to be done, need to be conducted through software, through simulation. So you cannot see, you cannot see, so you cannot have experience. Okay, so you need to go to the second half. Okay, so the main reason why we choose C program instead of assembly, okay, like I said, easier. Okay, when things become easier, it will consume less time. Okay, so and then we can modify, we can update the program, okay, using, if you have any access to laptop, to PC, okay, and then the software is available, you can remodify, okay, remodify continuously again and again. And then the code, the library, okay, this library, I'm going not to explain very detailed, so this one maybe later on, okay, maybe next week and also the other week. Okay. This library, normally if you use, for example, if you're using MPLAB, there are built-in libraries. That one will make your life, your programming work easier, because all the code, you don't have to define everything, all available. You just call the library, and then C code is portable. Okay, so meaning that you can use it for PIC, you can use it for UPNEL, you can use it for ARM. Okay, so previous lecture I say that certain microcontroller have their own specific vendor. So by using C, okay, you don't have to move to another languages, because C is also available. You can use also, is also acceptable to program another type of microcontroller. So how does this program behave? How does the program resemble? So you can see here. Okay. But before that, okay, so how do we develop our program? Okay. So how do we develop our program? Looking at this diagram, is actually a problem. Okay. We want to measure sensor temperature, to be precise, temperature, which is an analog signal, and then using microcontroller, read that value, the temperature value, and then display it on LCD continuously. Yeah? Okay. Any changes will be updated through LCD. Okay. So the first thing, so you can see through this diagram here, in order to measure temperature, we need to use temperature sensor. Temperature sensor will be discussed later on, what type of temperature sensor, the characteristic, but right now, just to be brief, okay, we use temperature sensor, so any value, analog value, will be converted to digital, to electrical, to digital, and then that value will be transferred to AD. So basically, the sensor will read analog value, and then it will transform into electrical. So the analog value will be transformed into digital using built-in AD. AD stands for analog to digital converter. It will convert analog value into digital. So this function, this hardware subsystem consists inside this microcontroller. Okay, so that particular hardware subsystem will do some kind of manipulation, calculation, and convert the digital value into temperature. So basically, we can devise up to 4 steps in order to tackle this problem. Whereby the first one, we need to activate and build in ADC. So using microcontroller, we don't have to worry about ADC because it comes embedded. It comes embedded inside this microcontroller. So yeah, we need to do proper configuration in order to use this ADC. Okay, so activate, then measure the analog value using the sensor, and then the value will be obtained through ADC, analog to digital converter, and then it will do process, will do processing and also calculation to convert that value into temperature, and then it will then transfer the temperature data to LCD. So we have up to 4 step solution that complement each other, related to each other. So from this step, we try to write program according to the respective solution. Okay, starting from number 1, number 2, number 3, and number 4. Okay, so by using C language, we write 4 functions that resemble that represent 4 type of solution. Okay, so this is simple program structure in C. Okay, so this is the top of the program, then the middle, then the other one. This one is not related to the program. It has no effect on the program. Also, the top one. Okay, so you can see here. Okay, start with slash and then star, slash star or asterisk. Okay, and then anything that you type after this code, and then followed by closing, star and then slash, is not going to affect your program. So we call this comment. Okay, you can write down anything. Okay, the author of the program, your program name, when the date of this program, the version number, and so on. Anything related to the program. Okay, so any code written inside this code slash star the program. Okay. Same goes for here. Whenever we have a last sentence, okay, one paragraph of sentence, okay, we just put on the first and then on the last sentence. Okay. So everything will be disabled, have no effect. But if you want to put comment on every line, so we use double slash. Okay. So double slash only valid for single line of or one sentence of comment. So as you can see here, okay, the purpose is the same, comment, but how we present? Okay, this one, what you see here, we use double slash. Okay, this one comment refer to this code. Okay, and then the second line refer to this code. But the main here, which is we call it function, is the program itself. It has effect on the hardware. Okay, so this one need to be coded, writing program correctly, okay, without any errors. Okay, so this is the how you write down the program. Okay, this is the actual program. Okay, later on I will explain. Okay, so basically, the program we can represent in the form of this is the main program. Okay, everything whenever you run the program, it will go to here first. Okay, to here first. Okay, so normally, how do we write down the structure? How to start with void and then main. The name, the code is fixed. Okay, you cannot change. And then the case also sensitive. Everything must be lowercase. Same goes for main, and then you followed by a space, and then open bracket and then close bracket. Okay, and then you put on open curly bracket, and then close curly bracket. So any code you put between here will be conducted. Okay, code any code. For example, this one. Okay, so it will be conducted within this function. Okay, if you put after the closing bracket, so that one will not belong to the main. Okay, so how first thing we will start with the main feature or the main loop or the main subroutine, which is called main. Okay, from here you can put any command, any code that you intend to do. Okay, so this is the complete version. Okay, so as you can see here, the first one, the first section here, looking at the first line, the top is the compiler's definition. This is where you put your compiler definition. Okay, so when you are doing with PIC 16F, the compiler must be xc.h. Okay, if you are a different model, you need to put different compiler. Okay, so but right now for PIC 16F, the compiler is xc.h. So followed by angle bracket, okay, open and close. Okay, so the code must be same. Okay, and also case sensitive. It is very case sensitive. So you need to follow up. Everything must be lowercase. And then after that, the configuration setting related to the microcontroller. Frequency of the oscillator, what type of oscillator, watchdog timer, whether you want to enable or disable, power on, enable, and then Boran, brown out, enable, and then low voltage warning. These are the important items that you need to include. Okay. For here, you define our the microcontroller oscillator to be HS. Then you enable watchdog, and then you disable watchdog, and then you on the power time, and then brown out, you disable. Okay, this code need to be included. Okay. You need to refer to the previous lecture. Okay. For simulation, some of the coding line need to be excluded. Okay. But for actual hardware, we need to include everything here. Okay, and then the last one, okay, you define what is the frequency of the microcontroller. Okay, so for this case, our frequency of the microcontroller is 20 megahertz. How do you know? That one is related to the hardware. Okay, so what is the value of the crystal oscillator connected to your microcontroller? If it is 8 megahertz, you put here 8 megahertz. Okay, so everything must be same with the actual hardware. And then after that, you start with the main subroutine. So void should be put here, okay, main, and then open bracket and then close bracket, and then followed by curly bracket, open curly bracket and then close bracket. Okay. The line, the code should be put within this subroutine. Okay. So anything put here belong to the main subroutine. Okay. So for the first one, we initialize the control register, and then after that, we do continuous looping. This one will be explained later. Okay, so you can see from here, we start the initialization, and then after that we go for the main looping. So the main looping is not necessary, depend on the program, which I will explain to you later on. Okay. So before we proceed, we need to know some of the fundamental of C programming. Okay, by the first one, we're going to look at some of the data operation. So basically, for data operation, for computer, for program, for microcontroller, is to carry out operation. Also, other type of data processing. It can be ADC to LCD, can be calculation, conversion, binary to ADC, BCD to binary, and so on. Okay, calculation, you want to add to calculate something. So basically, this data structure consists of different numerical and character variable. So the keyword here is variable. Okay, so later on, variable is very important to C programming. So you will see later lah. Okay. So the variable can be numerical and also character. Okay. So this variable is limited to arithmetical and or logical operation. So whenever the programming is doing whether arithmetical and also logical, or either one or both, the variable the data variable is important. So the data variable can consist of numerical and so character. That one we will see later. Okay. So why? Okay, so why this is important? Okay, sometimes we need to focus on the processing speed. So this one I will explain later why processing speed is important. Okay. Right now we need to know in order to define an efficient program, the parameter, especially processing speed, is also important. That one I will explain later. Okay. So looking at the variable, okay, so therefore we can say that the variable consists of several types. Okay. Basically, there are 4 types. We call it integer. It can be belong to integer. It can be belong to float, and also double. This one is not related to program. N, A, N, D. Okay. So what is variable? Any changing number. Okay. Let's say that initial number value is 10, and then that number continue to change. 10 rising, increasing. Okay. So we call it variable. Okay. So variable, we use variable when we want to store data value. Okay. We want to assign value, and also we want to assign a result of our calculation of the program. We store it in variable. Okay. Provided that that number is changing. Okay. But if the number is not changing, that one we will see later. But right now, we only use variable to store changing value. And this variable need to be named. You need to put specific name that is related to that particular variable function, what it is intended to do, and then this label will be stored in a specific location. You don't have to store it, the programmer will store it automatically. You just label, put nice name on the label, on the variable, and then after that, the microcontroller, the program will assign specific location. Okay. And how do you assign? So basically, the first thing that you need to do is you need to declare first. Okay, what are the variables? Okay. So after you declare, the microcontroller will locate that data required by certain operation. Okay. If you want to use a certain particular variable, you need to declare. If you declare and you don't use, okay, not efficient. You are not optimizing the program, and also it is affecting the processing speed. Okay. That one is the first condition. Okay, so there are 4 basic type, integer, character, float, and also double. So what are the parameter of this type? So looking at the next slide, so you can see here, we have unsigned char, signed char, unsigned int. Int stand for integer. Okay. If you are writing C program, you need to follow this type of syntax, because C programming is very case sensitive. It's case sensitive, so you need to follow. Okay. So what is unsigned? What is signed? So you can see here, the keyword here is similar, except for the group. Okay. We have unsigned child, except for the type. Okay. We have two data type. Two data type of our variable. Okay. For each of the group of the variable. Okay. For child, which is character. Character is actually an 8-bit data. Okay. Why 8-bit? Okay, so in order to understand what is 8-bit, what is 10-bit, okay, so to make your life easy, you can use the install calculator in Windows. Okay, make sure that you change to the mode into programmer. Okay, so what is 8-bit? Okay, so 8-bit you need to refer to binary. So 8-bit is actually here. Okay, 1 0. Normally we will start, we call it location 0, but total number of bit is actually 1, 2, 3, 4, 5, 6, 7, 8. So this is 1 bit. Okay. It will contain value okay, up to 1 bit. So what is the size? Okay. If 0, it will start with 0, and then the final, the maximum value is 11111. Okay. So what is the size? Okay. So you can see here -1. Okay. This one, why? I will explain later. Okay. But right now, okay. So this is the total 8-bit is 1 byte. So half byte contain 4 bit, 4 bit, 4 bit. Okay, this is binary notation. And then we have hexadecimal notation. So one character equivalent to 4 bit. Okay. And then this is the size. Okay, starting from 0, and then this is the limit, the maximum value 2.5. This is decimal. This is decimal. This is 8 bit. Okay, this is 8 bit. Okay. So we have 8-bit. So unsigned char is reserved for 8-bit data. So if your data in the range of 0 to 255, you can assign it to char. But if your data is larger than 255, maybe 300, 400, that one will be see later. Just right now, if your data in the range of 0 to 255, you can use unsigned char. So what is unsigned char? 8-bit of data in the range of 0 to 255. So you can see here, the number is positive 0 to 55. So it is most widely used because why? Why? Because the size here is smaller compared to the rest of the data type, variable data type. And then unsigned. Unsigned refer to the positive value. Okay. But for signed, is refer to the positive and also negative value. And because the size is 255, we need to assign half portion of 255 as negative and the remaining half portion as positive. So that's why negative 128 to positive 127. Okay. But this is actually similar 8-bit data. Okay. Depending. So if your data is 200, maybe you can declare it as unsigned char. You can declare it as signed char. But if the value is negative, let's say -1, you need to assign as signed char. Okay. So why we need to properly assign, that one I will explain later. Okay. And then we have another data type which is unsigned int, similar to the previous one, unsigned and also signed. Unsigned means that it is positive number, but the bit size is 16. Okay. So whenever the bit data number of data bit is 16, so you can see the size is greater. Okay. 65,535. So meaning that you can put represent any data that have value larger than 255 for positive. And then for negative, also 16 bit, but we need to divide by 2. Okay. The first half need to represent negative value, and then the remaining one need to represent positive value. Okay. So you can use this for higher than 255 data. And then after that, the table that you see here represent the type of data. Okay, we will start with unsigned char. Okay, the size and also the range. The size is 8-bit. For 8-bit of data, which is in the range of 0 to 255, we can either declare it is unsigned char or unsigned short int. It will hold the same size, same data size. Okay. This one for positive, positive from row 1 to row 4. This one for positive number. If the data size is larger than 8 bit, okay, we can go for int or integer. Okay, the range, okay, the range is from 0 to more than 65,000. Okay. And then if the data is still larger than 65,000, let's say the data need to you need to assign up to 70,000. Okay. So you need to declare it as long int, long integer. Okay. For unsigned, this means that the data need to be positive. Okay. This one is 32 bit, okay, larger than the previous one, 16 and also 8 bit. Okay. This one for negative. Okay. This one for negative. And then if you refer, we also have decimal point. We have fraction. Sorry, we have fraction. So fraction, the size of fraction is 32 bit. So if you want to put fraction value, let's say the value of 5, 3.142, and so on, so on. Okay, you need to assign it as, declare it as float. Okay. So this one, the value is larger, okay, up to 10 power of negative 38 and also positive 38, the range of that. Okay. You can also go for double, okay, but the size is similar, okay, starting from long, float, double, and also long double. So you can assign, declare according to the size of the data that you need to program, need to assign. And then the numbering format. Numbering format, like I said, like I show you, okay, we have 4 type of numbering format: decimal, hexadecimal, octal, and also binary. Okay. This one, when you want to write the program, okay, when you want to assign decimal value, you need to put the correct decimal value. Okay. Why? Because every format, even though the value is the same, but for different format, it will give different notation. Okay. So in order to do correct format, in order to write in correct format, you need to put. Okay. If we don't write decimal, we don't write hexadecimal, we put it in the form of code. Okay. For decimal value, we don't have to put anything. Okay. It can be 300. Okay. So this 300 belong to decimal. Okay. But what if 300 we want to change it to hexadecimal? So we need to put 0. This one is 0, not character O. Okay. So this one, many of you during programming, they made mistake. Okay. Small mistake. They don't know where, and then when they want to compile the program, it will give error. Okay. So make sure that this one should be 0. Okay. Numbering. Okay. And then also whenever you write program, you need to differentiate which is number, which is alphabet, because some character have similar sign, similar representation. For example, 0 and also O. Okay. So you need to know. Okay. But if you want to declare your number as hexadecimal, it must be 0x, okay, or 0 capital X. That one for hexadecimal, and then for octal, it must be 0, and then followed by the number that you want to put. And then the last one, binary. For binary, you can either put 0B or 0 capital B. Okay. How do we write this? For example, if decimal, for example, in decimal, you just put let's say 200, you just put 200. Okay. But for hexadecimal, you need to put 0. Okay. This one is 0, not O. Okay. X, and then followed by the number, okay, which is let's say 3F. this value is hexadecimal, or can be 0, F, 1, 0. Okay. Depend on the format. And then for number 0, start with 0 and then followed by the number value, 200, 300, and so on. And then for binary, start with 0 and then B, either small b, lowercase b, or uppercase b. Then should be either 1, 0, 1, 1, and so on. But the size must be 8-bit. Can be anything. So total out would be 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is the notation format that you need to know whenever you want to assign numbering. So we continue with assignment operator. So previously you have already been explained what is the data type, what is variable, what is the type of variable, the characteristic, and then later on, starting from this slide, we're going to look at assignment operator. So what is assignment operator? It is actually a range of arithmetic and logic operation. Okay, logic and arithmetic operation when a single or pair operand are processed. So basically, it involves either arithmetic, logical, both, or either one. Okay, so it can be the operand, the operand can be single or pair, which I will explain later on. Okay, the result from this operation is assigned to one operand variable. Okay, so you can see here, you already know what is a variable. You have been explained what is variable. So you need to assign the operand with the correct variable. It can be single, it can be third, so on, depending on how many variables needed for that particular operation. And then assignment operator is equal to, so you can see here, this is actually equal to, 1 equal to, not double. Later on you will see, so I don't want you to be confused between single and also double equal sign, because they give different result. Okay, they have different job scope and also they give different result. So right now, assignment operator. So this one, when you see single equal to, it is belong to assignment operator. We also have other type operator which you will see later. But right now, for equal to sign, it is belong to single operator and used to give the variable value of an expression. Let's say you want to assign 0 to I, so I is the variable, and then 0. So what is data format for 0? Apa tahu? Data format dia apa? Number format, sorry. Number format dia apa? What is the number format? 0, and then X, another variable equal to 35. Apa tahu? Anyone know before I start calling? Okay, so today you're going to have very long lecture. Okay, complete with question and answer. Okay, we will start with the first one. Abdul Hafiz, absent or present? Abdul Hafiz, datang ke tak datang?
Yes, sir.
Ya, Abdul Hafiz. So looking at this slide, PowerPoint, so you
Yes,
can see,
sir.
okay, so you can see here, I equal to 0. 0 is a number, X equal to 35. 35 is also number. So I is a variable, X is a variable, equal okay. So you can see single operator equal to 0. 0 ni is a number, 35 also number. So 0 belong to which data format? 35 tu belong to which data format? Power tadi saya ajak.
0 decimal.
Okay. 35?
Decimal kak.
Dua-dua decimal. Terima kasih kerana mencuba. So boleh sambung kelas.
Okay, boleh.
Okay, so the correct answer is decimal Okay, so correct answer is decimal. So right now we assign Okay, so we assign value of I and also x, okay, whereby I equal to 0, x equal to 35. And then operation, okay, what is the operation? We want to add between variable A and variable B. Okay, so we assign another variable, okay, whereby A sum is will store the result of this assignment operator A plus B. Okay, so we have another variable I, X, A, B, and also sum. So we have 1, 2, 3, 4, 5 variable. Okay, so that one is okay. I have another question. Okay, data variable type. Okay, we know that the format is decimal. But what is the data type that we can assign for I? Data type. Kita ada 4 data type. So we have 4 data type. Siapa tahu? Tak apa, kita panggil ya. Semua akan mendapat peluang yang sama. Jangan risau. Abdul Rafiq sudah. Aisyah. Aisyah, absent ke present?
Yes, sir.
Aisyah. Okay, another question. Okay, so we know that the number is decimal. Okay, so looking at the first code here, ini nampak? Okay, the first code. I is equal to 0. Okay, so this variable I tu kita tahu variable. So it belong to which data type? And we know that there are 4 data type. So which data type that we need to assign? Kita ada 4 kan? 4 data type. Data type pertama apa dia? Aisyah?
Sekejap, sir.
Cuba tengok balik nota tu. Dia ada 4 kan data type tu. Data type tu. Variable, sorry, variable type.
Unsigned char.
Okay.
Short.
Kalau okey, yang tu awak tahu kan. Jadi sekarang ni untuk I ni kita nak letak dalam data type yang mana satu? Char ke, int ke, float ke, apa, double ke, integer ke, mana satu yang sesuai? Sekarang ni 0 tu positif kan negatif number?
Positif.
So positive. So the first thing that we can know, can decide that it is apa? Positive value. Apa dia? Positive value kita panggil apa? Number tu positif. Kita panggil apa? Siapa tahu? Number tu kita panggil apa? Type apa? Tengok balik nota tu. Number tu type apa?
Unsigned.
Unsigned Okay. Unsigned Okay, unsigned. Okay, sebab apa? Because 0 lah. Okay, 0 from 255. Okay, 0.255, 0.0 to 65,000, 0 4. Ini banyak ni saya tak tahu apa-apa. Okay, so it can be assigned lah. Okay, so nak letak kat mana satu? Char ke, short ke, int ke, long ke? Okay, tak apa, terima kasih. Tak apa. Kita pergi ke seterusnya lah. Cho Xin Yuan. Okay. Cho Xin Yuan.
Ada.
Okay. Ya, nak letak dalam which type? Okay. So we know that the number 0 is positive. So therefore we can say that the first type should be unsigned. And then we need to assign which variable type?
Unsigned character.
Unsigned character, unsigned char. Okay.
Yeah.
We can assign unsigned char. Why? Because the value is 0. In one, okay, thank you very much.
Okay.
So in one, we can also assign char. Okay. Bagaimana kalau saya assign dia sebagai int? Unsigned int. Boleh ke tak boleh? The next one. Farah Auni. Farah Auni. Ada ke tak ada?
Ada sir.
Ada. Okey. Jadi boleh ke tak boleh kalau saya apa? Saya declare dia sebagai unsigned int integer. Boleh ke tak boleh? Tengok balik nota tu. Okay, tengok balik jadual ni. Sekarang ni nombor dia nombor positif. Okay. Dia kita boleh letak pilih mana satu lah. Tapi kawan nak buat kata assign char. Yang tu pun betul. Tapi kalau saya tak mau letak assign char, saya nak letak unsigned int. Boleh ke tak boleh?
Boleh.
Boleh. Sebab apa?
Sebab dia zero.
Sebab dia zero. Okay. Okay, terima kasih.
Okay.
But well, even though we can assign int, we can assign long, but you can see here the size, the range is larger. Okay, so whenever you assign larger size of data or variable type, this is what I want to show. Okay, whenever you assign large data type, the processing speed will be affected. Okay, so that's why you need to correctly assign. Okay, kalau data, if the data between 0 to 55, you can either use char or short. Okay, why? Because your decision, the identification, the declaration of the variable type will affect the processing speed. Okay, processing speed. If the size is larger, okay, the processing will be slower. So you need to properly, correctly assign. Okay, so we move on. We move on. So we move on. Okay, this is assignment operator. Okay, this is the typical example lah. Okay, then we look very detail lah. Okay, so assignment operator. This is the operator lah. Okay, the operator. Okay, we have 1, 2, 3, 4. 4 type of operator. Okay, so starting with plus equal to, minus equal to, star equal to, slash equal to, percentage equal to. Okay, this is the sign. So for example, this is the most common. A equal to 8. So this means that we assign value of 8 to variable A. Okay, so we can declare it as, so we know that 8 is positive number. So therefore, we can declare it as unsigned. Since 8 is smaller, between 0 to 255, we can either declare it as unsigned char or unsigned short integer. Okay, why? Because lower than 255, higher than 0. Okay, other type of assignment operator you can see from this table. Okay, okay, this is the operator and their function. Okay, normally for plus equal to the expression. Okay, for example, is we say A plus equal to 8. Okay, so referring to this example, A equal to 8, and then we assume because whenever you write a program, you need to declare the initial value of your variable. Okay, for this case, the initial value not declared. Okay, so right now we just assign A is equal to 8. Okay, so we know that A is equal to 8. So the expression for expression A plus equal to 8. So it is equivalent to actually A equal to A plus 8. So whenever A is equal to 8, so 8 plus 8 equal to the new value of A, 16. Okay, faham? We just substitute value according to the declaration. Declaration. Okay, and then the next one, minus equal to. Okay, A. Okay, this is how you write in your program expression, the syntax. Okay, A minus equal to 8. So this means that 8 minus 8 is equal to 0. So the new value of A is 0. by assuming by assuming that the initial value for A is 0, then the next value is equal to 8. Okay. So any value, any new value will be updated here. Okay, updated here, and then star equal to, so this is actually variable A multiplied by 8, and then slash A slash equal to, it is representing division, and then the last one okay, modulus equal to is actually division, and then we refer to the remainder of that particular division. So let's say A is equal to 8. So 8 divided by 8, it does not give any remainder. So we return the value as 0. Okay. Let's say A is equal to 16. 16 divided by 8. Okay, 2, no remainder. So the return value, the result value is also 0. Okay. But what if the value is let's say 17? Okay, so 17 divided by 8, so we get 16, and then the remainder is 1. So it will return the value of 1. It will return the 2 operand division. Okay. So provided that the value is available. If the value is not available, it will give 0. Okay. That one is assignment operator. We also have bitwise operator. Okay, they both are completely different. Okay, but they are using the same character. Okay, so you can see from here. Okay, you can see from here. Okay. So unlike logic or operation being performed by a variable, so previously we have assignment operator. So in order to execute the process, we need to assign variable. But for bitwise operator, logic operator being performed auto variable, the bitwise operation perform single bit. Okay. So let's say if the value is 2, it will the operation will take place within the bit. Okay. So if the data is 8 bit, so between each bit of the 8 bit, the process will take place. Okay. So basically, we use bitwise to modify the bit of the variable inside the value. So this is the character that we use in order to write bitwise, in order to perform bitwise operation. Okay. So each character represent their specific assignment. Okay. So for example, this is a curly or wiggle character. Okay. So this is how you write in your code: A equal to curly B. Okay. This is the value. Okay. We assign B the variable B as 5. So result A bitwise complement of B is equal to -5. So why -5? This one you need to refer to your to extra note. Okay, this one already, I think, already been explained in previous courses. So I don't want to explain the detail, the theoretical part. You can also use this one. Okay, you can also use this one. Okay, why 5? So this is decimal 5. Okay, so decimal 5. So bitwise is actually the process of inverting single bit. Okay, so you can see here. Okay, the bit is for 5. For 5 decimal is 1010, and then we invert by using not operation. Okay, so this is the value. Okay, and then we need to pass 1. Okay, so bitwise bitwise complement of A equal to, of A equal to bitwise complement of B. Okay, when B is equal to 5, the result will be -5. So for bitwise complement, there are specific equation. Okay, so in order to calculate it manually, okay, so you need to refer to your textbook. Okay, but if you want to do it okay, without calculation, you want to do correct quickly, okay, you just use this calculator. And then for the next one, okay, this one we call it shift left. Okay, so for example, code return here is A is equal to B shift left 2. Okay, this means that we are shifting the bit, okay, not actually the number. Okay, for example, for this one, the value of B is 1110011. So you can also use calculator binary, binary 1110011, and then shift, shift to the right, okay, shift to the left. Sorry, shift to the left 2 times. Okay, 2 times. Okay, 2. Okay, so the value, the new value will be 10110011. Okay, so why we have extra bit? Because it is in the form of word. Okay, you can also use byte. Okay, so this will give you the correct value. Okay, 1100 1100. Okay, and then the next one, and then the next one, shift right. You can also do the same thing, except that different is the direction. Okay, the first one move to the left, and then the second one move to the right. And this one you need to put how many bits that you want the shifting process to continue. Okay, how many number of bits. Okay, for this case, shift to the left to 2 bit, and then the second one shift to the right 2 bit. And then we also have this ampersand code n. Okay, so this one represent process, we call it bitwise n. So this means that we end between A and B. So again, this is the value of A and B. So this is the result. Okay. So for n, basically the theory is quite simple. Okay. If the value is 1, both value 1 or true, it will give 1. The result will be 1. So for this example, 1 0 0 1 0 0. This one will give 0 0 0 0 and then 1 1. Okay, that's it. Same goes for all. Okay, any one it will give output 1. Okay, this one 1 1 1 1 0 and then 1 1 1, and then the last one bitwise exclusive OR. Okay, so this is how you calculate okay? A and B, the value, the variable of A, the value variable of B. Okay? Data in binary, so the output is 0 0 1 0 then 1 1 1 1. This one you can do it by yourself. Okay, so you need to understand. Okay, in order to make sure that your program run correctly, you need to know okay, some of the operator okay, belong to each group, either bitwise or assignment, and then make sure that you know the syntax, the code, the character, okay? Because some of the character almost the same, almost similar. Okay? So as you can see here, bitwise n. Later on you will see they are double n. Okay? The character is similar, but the function, the process different. Okay? So need to know. Okay? Later on you will see double n, double o, and so on. So we have exercise. Okay. Assume that A is equal to 0x27. So So this number is actually what? Variable format, number format. Apa dia? Hexa format. Okay. NB is binary. Okay. So we have this one. Okay. A shift to the left, 3 bit. Okay. So this one you do it by yourself. A and B, and then plus one for number 4, port C. Okay. We have variable port B, A, Z, B, port D, A, B, and then port C. Okay. Output port B, Z, port D, and port C. Okay. This one you do it by yourself. Okay. Later on, if you have problem, you can ask me. Okay. I don't want to spend time okay, for this exercise. Easy. So we move on to arithmetic and logical operation. Okay, so what is arithmetic? What is logical? So you can see here. Okay, arithmetic will perform arithmetic function okay, related to the number. While logic, you will see next one. Okay, logical operation. Okay, so you can see here the syntax, the character related. So looking. The first one, we have single operand. This one, arithmetic operation. This will be the operand. Okay, the operator double plus, okay, double minus. Okay, so need to observe very careful. Okay, this one is double. And then we have one wiggle. Okay, one curly. Okay, curly. Okay, so this one is single, this one is double, this one is double. So whenever you see double or single, so double plus means increment. Okay. We increment the value. So the coding written here, shown here. Okay. Our output is result, and then we need to increment the variable num1, okay, followed by plus double plus. So mean that we are increasing the number. Okay. So let's say original number is 0. So by putting double plus, so means that the number will increase. Okay. Depending on how many times the code here is written and also executed. And then followed by number minus. Okay. Let's say initial value is FF, okay, or 255. Okay. So it will reduce. To 0. And then after that, starting from 255, 254, 253, 25 on. Okay. Decrement. Okay. Depending on how many time you call this code, how many times you write the code. Okay. Is for single process, it will only decrement one time. Same goes for top. And then the complement. Okay. The complement means invert the whole thing. Okay. The whole bit. Okay. If 0, 1, 0, 1, so it means that 0 will become 1, 1 will become 0. Same goes for the rest of the bit. Okay. And then we have arithmetic operation. This one involves mathematical. Okay. So make sure that the data is in the form of binary. Okay. So the output is result, and then we have two variable. Okay. Two variable, and then this is the operand, plus, minus, star, which stand for multiplication, and then slash, which stand for division. Okay. This is the initial value. So for plus, the initial value of variable num1 is 0, 0, 0, 1, 0, 1, 0. The initial value of num2 is 0, 0, 0, 0, 1, 1, 1. Okay, so adding these two bits together, so 1 plus 0 is 1. Okay, 1 plus 1, okay, carry 1. So the new value will be 0, carry 1 here. Okay, let me show. 1, 0 should be 1, and then 1 plus 1, 0, carry here. Okay, 1 plus 0 plus 1, so 0, carry here, 1 plus 1 plus 0, So 0 carry here 1 plus 0 plus 0 1 0 0 and 0 8 bit 1 2 3 4 1 2 3 another one here. Okay. So 8 bit. Okay. So the value the final output is 0 0 1 0 0 0 1. Okay. And then for minus minus subtraction okay. Number 1 minus number 2, this is the value the original value. This is the original value. Okay, so we subtract between these two numbers. 0 minus 1, so need to borrow from next bit. Okay, so the number here. Okay, 0 minus 1, borrow 1 from front. Okay, so become 1. So the value is 1. And then since the value here is 0, so borrow from here. This one borrow from here, this one borrow here. So 1 become 1. And then this one, okay. So since borrow from here, so 1 become 1. And then this one already 0, so the rest will be 0, 0, 0, and 0. Okay, so this is the final value. Okay, so we move on. Multiplication, simple lah. Okay, we just multiply between 1 and 0. Okay, 1 and 0. 1 multiplied by 0 multiplied by 1, 0 multiply 1, and so on. Okay, this one easy. Okay. But for the last one, it's very difficult because you need to perform correct division. Okay, so for example, if the value here is 0, 0, 0, 1, 1, 0, 0 divided by 0, 0, 0, 0, 0, 1, 1. So this means that you need to divide. Okay. So whenever you divide this one, I will show. So very complex. Okay. So you can use your calculator. Okay. You can use your calculator. Ada soalan? Okay. So we move on. We move on. So we move on. This one, the previous one is for arithmetic, okay, for mathematical computation, and then the last one. The last one is actually logical operation. Okay. This one logical represent by single character, okay, and or, and then we have power exclusive for. So whenever you see this kind of character, so let's say num1 and num2, you need to perform logical and, okay, not you and both number. Okay. 1 and 1, so the output will be 1 or true. Okay. And then follow 1 0 0, and then the rest. Okay, anything that is not 1, not true, should give 0. Okay, same goes for all. Either value is 1, so this means that it will give output 1. Okay, any either value or both value. And then exclusive for. Okay, so exclusive for. Okay, you need to exclusive for between these two. Okay, so basically, num1, you need to, I think you need to invert num1 and then or between these two numbers. Okay. For this one, I don't want to show you. You need to perform by yourself. If you have any question, you can ask me. Okay. Through WhatsApp. Okay. And also you can ask later on. Okay. So for this exercise, this one do it by yourself. Okay. So try to do it by yourself. If you have any problem next week, we're going to see. Okay. So you can ask me again. So right now, I want you to do it first. Okay. So you can see here, this one related to the previous operation, logical, also arithmetic operation. Okay, so we move on. The next one is the conditional operation. Okay, previously we see a type of operation. We have logical, we have arithmetic, we have logical, and then the next one is conditional. Conditional is just used when logical condition is tested. Okay. Normally we test it. This one I will explain later lah. Okay. For looping, okay. For while loop, if loop, or for statement, okay, we use logical operation. So this looping, where the parameter, the condition for this looping to be executed is depend on the logical condition. Okay, so how does this perform? The variable is compare. Okay, the keyword is comparison. Okay, not mathematical operation, not being added together, divided together. You just compare between variable, set of variable, another variable, and then if the condition is true, the remaining part or the code between that particular statement, that particular process, for example, for while loop, if loop, or for segment, if true, then it will execute that particular operation, okay, or process. So this is the syntax code that you need to follow, okay, whenever you want to do conditional operation. Okay, so you can see here, okay, last time we have single equal to, so right now we have double equal to. Okay? Very different, okay, very different. One equal to means that we want to assign our variable with any value, certain value, okay. But for double equal to means that we want to compare. Okay? If A double equal to 0, okay, so whereby the condition is B equal to B plus 1. So if A is equal to 0, so this means that the condition is true. And otherwise, the condition is false. Therefore, it will not be executed. Okay, same goes for the rest of the symbol. Okay, this one not equal to, okay, not equal to. If A is not equal to 1, so this means that A not equal to 1. A can be 10, can be 100, just as long as it is not equal to 1. If that particular condition is true, then the rest of the code will be executed within this block of this statement. And then greater than, so you can see here, okay, single, okay, single bracket, angle bracket, okay, same goes from here, greater than, less than, okay, need to know, okay, between the difference between single and also double. Okay, so for this one, greater than, so this means that if A greater than 2, do this, okay, B equal to B plus 3. Okay, so A is greater, so A is 3, 4, 5, 6, so on. Okay, so this means that the condition will be true, and then it will do this code. It will execute this code. And then less. Okay, if A is less than 3, do this, and then we have combination greater and then equal to. So this means that it can be either equal or it can be greater than the condition. Okay, for the example, A greater than equal to 4. So this means that A can greater than 4. It can be 5, can be 6, can be 7, and so on. As long as the value is higher than 4, and A also equal to 4. Okay, so if that condition is true, then it will begin execute the following code. The other one, the last one, the last row, combination between less than equal to, same goes like the previous one, but the condition is that the value of A must be less than 5 and also equal to 5 for this condition to be true. If true, proceed with doing this code, executing this code. Okay. So we also have AND condition. So you can see here AND condition and also OR condition. Okay. AND, single AND, double AND is not equal to single AND single OR is not equal to double N or double OR. Okay, they both give different output. Okay, so if you see double N, so this means that you are doing conditional operation. So if this condition, the first condition is true, and then followed by the second, so this means that we can execute the rest of the code within this statement. Same goes for OR. Okay, if the condition is true, only execute, but not performing arithmetic operation. Okay, so need to differentiate between the number of characters. Okay, this one, okay, similar, very simple. Okay, if negative A is higher, equal to, greater than equal to 0, okay, condition is either true or false. So we know that A is equal to 10. So negative A, negative 10. So this condition will not become true. Okay. Why? Because negative 10. And then the rest, you can see the last one, A is not equal to 3. Okay. So we know that A 10, so 10 is not equal to 3. So this one will give true, true output. So you can do the rest. Okay. So we know, previously we know that for variable, the data is always changing. Okay. Any number that can change. Okay. But what if the number is constant? Okay. Remain fixed throughout the rest of the code, throughout the rest of the program. So in order to do that, we can also use constant number. Okay. Integer that is constant can either be decimal, hexadecimal, octal, and also binary. Okay. Just as long as it is constant. Okay. Therefore, you can use this type of declaration. Okay. The compiler recognize the constant number through keyword const. So whenever you use const and then followed by the number value, okay, it can be decimal, it can be hexadecimal, it can be binary. Just as long as you put the word const first, so it is actually constant. So this means that the value will not change. Okay, the value will remain the same throughout the rest of the process, throughout the rest of the program. Okay, so declaration is similar to assigning variable. Okay, you can start with const, int, and so on. Okay, how you assign variable. Okay, how do you assign a variable? You can also do the same thing for constant. So for this example, this is for number type, for variable constant type. Okay, we describe constant first. So this means that 100 is the same throughout the, and then the number, the name. Okay, it can be max, it can be min, any value that you know. Okay, represent something, you can put. It can be decimal, hexadecimal, octal, and also binary. So this is how you represent. And then the rest, okay, is the data conversion. Okay, so what is BCD? BCD stands for binary coded decimal. Okay, it is actually part of the numbering system. Okay, so why we need to learn about BCD? That one I will explain later. Okay, so basically there are two types of BCD. The first one unpack, the second one pack BCD. So what is pack? What is unpack? Pack is actually the first lower 4 bit half byte. Okay, shown here. Okay, 4 bit, 1, 2, 3, 4. This is actually unpacked BCD. Unpacked BCD. And then for packed BCD, single byte. Okay, so pack is only 4 bit, but for pack to be 8 bit. Okay, or 1 byte. Okay, single byte that has 2 BCD number in it. So you need to have another BCD. Okay, so 1 BCD, 4 bit. So another one 4 bit. So equivalent to 1 byte or 8 bit. Okay, for example, 0101 100 is packed for BCD for 59 hexa. Okay, so you need to do conversion. Okay, so this one unpacked, then if we double another BCD, so total we call it pack. Okay. So why we need to do BCD? So because it is related to ASCII. ASCII stand for ASCII double I stand for American Standard Code for Information Interchange. Okay. So what is ASCII? Why ASCII? So the purpose, the definition, the characteristic first, the base, it is contain 7 bit, okay, not 8 bit, 7 bit character, yeah, including upper and lower case letter and the numeral and punctuation mark found on the standard computer keyboard. So meaning to say that the keyboard, it can be your computer, your laptop, your tab, anything that contain character, character, alphabet, number, it is represent in the form of ASCII. So what are the characteristics? It is actually 7 bit, not 8 bit, but 7. Okay. So this 7 bit will represent each code of the character in your keyboard. Okay. Capital P, lower P, they all have specific representation of ASCII code. So because newer microcontroller have a real-time clock, where the time and date are kept, even though the power is off, the microcontroller, the computer, have a built-in RTC, real-time clock. So this clock, even though the power is off, it will still continue working, counting, updating to the current date. Okay, so that's why we need BCD, so that the data inside the microcontroller or the computer, we provide them in the form of packed BCD, and then in order to display, we use it to we use ASCII code. Okay. First, we transform to be either packed or unpacked BCD. And then from here, we convert to ASCII. So how we convert, you can see from this table. Okay. So the table represent each character of your keyboard, okay, in your keyboard. So starting with space, starting with this asterisk, and then we have and we have bracket. So everything that you see in your keyboard will represent in ASCII code. Okay. So this one is character, character, number, and then alphabet, uppercase, lowercase. Then we also have function, delete, and so on. Okay. So each have their own representation. Okay. So this is why it is actually 7 bit. Okay. This is the top one, 3 bit, and then followed by low bit, 4 bit. So total will be 7 bit. Okay. So what if we want to display character A? So the ASCII code should be 100, and then followed by 000, and then 1. Okay, so that one will display A. For example, okay, so this is actually 7 bit, okay, or 65 octal, 65 octal 10, okay, base 10. The statement for answer character Y, capital letter Y, will assign to the value of hexadecimal 59, okay, to the variable answer. If the hexa value is 59, okay, when we want to transform it into ASCII, it will give output result capital Y. Okay, so how do we transform? Okay, from looking from pack and also unpack. So using RTC problem, since we know RTC provide in the format of time of a day, starting by hour, minute, second, and then the date, followed by year, month, and day. So everything need to have their own character and also numbering. Okay, so how do you transform? Normally this data is provided in packed BCD. Packed BCD 8 bit. However, to convert packed BCD into ASCII, here you must first convert it to unpacked BCD. Okay. 8 bit, you need to convert to 4 bit. Okay, and then from here, the unpacked BCD is tagged with 0, 1, 1, 0, 0, which is equal to 30 hexadecimal. Okay. So you need to tag with 30 hexadecimal value. Okay. So first, okay, so you can see here we have two character okay, in the form of hexadecimal. So we need to separate. Okay. This one contain 4 bit. This one contain 4 bit. Okay. So you need to separate. Okay. So the new one unpacked representation of packed BCD is 02 and also 09. And then we need to take add 30 hexa. So in the end it will become 32. Okay. Why? Because 30 become 32 and also 39. Okay. This is the binary value of 29. Okay. So 8 bit, 8 bit, 8 bit. This one single okay, single, but also in 8 bit. Okay. And then the last one we represent it. We take by 2, so you can see here. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Okay, also 8 bit. Okay, but we can represent. Okay, so for example, 0, 32, or 0, 1, 0, 0. Okay, so and also 0, 1, 1. Okay, only taking 3 bit. Okay, 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, and then the lower half bit, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 0. Okay, 0, 1, 1. So it is actually character 2. So the display will give 2. Okay, so you need to do conversion for the rest. Okay, so how do we transform back to pack and also unpack BCD? So you can see here, to convert back ASCII to pack BCD, you must convert it to unpack BCD first. Okay, to remove the 3 here, the digit 3 here, and then combine to make pack BCD. Okay, first convert to unpack by removing the number 3 here. Okay, and for example here, okay, so for example for key 4, the ASCII code representation is 34. Okay, 34. So we remove the 3, remove the 3, so become 0, 4. Okay. So and then from here, transform it to unpack BCD, which is here and also here. Okay. So since the top, the higher first higher half, higher 4 bit is 0. So we can only represent here. Okay, so in the end becomes 0, 1, 0, 0. So this one stand for 4. Okay, and then for 37, remove 3, so become 1, 1, 1. Okay. So for pack BCD, become 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, and then 0, 1, 1, 1. Okay. So why? Because 7. Okay. For 47 hexa. Okay, so we look at so the next so the next one we're going to look at more advanced feature of PIC 16. So we're going to look at programming basic by looking at this item variable, starting with variable and then looping, and then after that we're going to look at decision, how this item being written, what are their function, and how does the decision being made. Okay. So how do you execute this? So we by example by reading data or controlling output, we are using this parameter statement here. Okay, and then the processing data, and then we are going to look at how decision being made. by referring to the output of the data. So the first one, variable. Okay. So we know variable is any value that changing. Definition. So how do we declare a variable name or identifier is a label attached to the memory location. So this one just a recap. Located on the specific location every time that you declare. Okay. So make sure that need to have a name so that you can identify. So in C, the variable label is automatically assigned to the next available location. So if you have more than one, okay. So the first one will be put the first location and then followed by the next of the variable, the following variable, it will move to the following location. The variable name and type must be declared. Okay, like I said, it can be char, it can be int, integer, long, float, double, and so on. It can be signed, it can be unsigned. Okay, so you must declare every time you want to use variable. Okay, only alphanumeric. Okay, AZ, capital AZ, or 09, and underscore here. Okay, not including the bracket. Okay, the middle one. Okay, this is underscore. Okay, not this one. Okay. Okay. Instead of space. Okay. So you cannot use space when declaring a variable. So you need to use underscore and use. And then you must declare first before you can use the variable. Okay. So how? You can see from this example. So basically, the variable name is x. Okay. Data type here is integer. So x is the variable. Okay. So we assign value using single equal to. So this means that x is equal to 99. And then from here, port D need to put value of x. So the value of x need to be transmitted through port D, display 39 in the form of binary 8-bit. Okay, so this is important. The name must be same. If you are using lowercase x, okay, so whenever you want to refer to the same variable, you need to follow the name. Okay, if lowercase x, so the next one, whenever you want to refer, you should also put lowercase x. Okay, and then the next one also same. Okay, because it is very sensitive. If you put different, okay, this will cause error whenever you want to compile the program. Okay, header file contain definition and function and also variable. Okay, you can also put header. Header, if you remember, we put on the first part. Okay. You can also put definition of variable over there. Okay. Because that one will be declared as global variable. So global variable you can use throughout the program. Local variable you can use inside this function, inside this routine only. So need to be different. Okay. If you declare global variable as x, also inside local variable as x, so will be conflicting. Okay. So will cause error also. And also content of variable can change. Okay. Variable need to know it can only put value that is changing. Okay. So we look at program looping. So program looping to execute continuously until the processor is turned off or reset. So whenever you call the continuous looping, it will continuously execute it. So looking at the example, okay, in order to enable continuous looping, you need to put while open bracket value 1 or true, okay, then followed by closing bracket, and then it must have open curly bracket and then followed by closing curly bracket. So anything written between open and closing will be executed provided that the condition is true. So for example, first you declare first the variable integer, whereby x is integer, and then when the condition is true, so you begin to execute this continuous looping by displaying the value of x in port D, and then you increment Okay, so you can see here double plus. So you increment. If x initial value is 0, so you increase to 1. Okay, and then you go, okay, you go back, okay, you go back, execute, display the value of x. Okay, since we increment it, so the new value is 1. Okay, then increment, previous value is 1, so increment becomes 2. Then display. So you will continuously executing. Okay, no stopping, provided that you turn off the microcontroller or you reset. Okay, that is the condition. Okay, so for decision making, okay, for decision making, to illustrate basic decision in making to change an output depending on the input state of an input. So what is decision making? We use decision making to make change, okay, output depending on the condition, depending on the state of input. So you looking at this program example. Okay, this one we refer only to the main subroutine. We declare first x, variable x as integer, and then the initial value of port D is 0. Okay, then begin to execute continuous looping. So x is equal to any value coming from RC0. Okay, and then you do comparison. Okay, if x is equal to 1, okay, then do this. Okay, then RD0 must be equal to 1. Okay, so different. Double equal to, single equal to. Double equal to, you are doing comparison. Single equal to, you are assigning value to the variable. Okay, so if the execution of the statement, okay, and then here will be the condition. Okay, so this one you will learn later. Okay, okay, in the form of starting from this slide. Okay, so they are other than condition looping, they are also for loop, break, continue, go to, and then the last one, if else switch. Okay, so you're going to learn this. Okay, starting from now. Okay, so we know that for while loop, it will provide continuous looping. Other than that, we also have do while. Okay, so between do and while is the program code. Okay, what you want your program to do, to execute. Okay, they both give almost similar. Okay, almost similar, but you can see from here. Okay, the difference is that for while loop, the condition before the block statement, and then for do while, statement will go first, and then it will check the condition later. So that is the difference. So example for while loop. Okay, so you can see here the condition is count must be equal to 6. Count must be less than 6. Okay, since initial value of count is 0, so 0 is less than 6, so true. Then start printing value, display value, and then after that, this is arithmetic operation. You add the value of count to 1. Okay, initial value 0, 0 plus 1, so new value is 1. Still true, do the same thing, and then repeat. Okay, new value 1, 1 plus 1, 2. So do the same thing until the condition become false, and then you begin executing outside the loop, outside the while loop. Same goes for do while, but you can see here, statement will be executed first. You execute the statement first, provided that also included condition I equal to I plus 1, and then check the condition. If condition is true, repeat. If the condition is not true, then go out from this looping. And then we also have for loop. Also loop, but different implementation. Why? Because we put condition, initialization, and also the process, the arithmetic process on the same condition. Okay. So this example, okay, we have main subroutine, declare first the variable of count, which is integer, and then you start by executing for loop. Okay. So for loop, so make sure that the condition here. For example, the variable initial value of variable count equal to 0, and then this is the condition. Count must be less than 6, and then start incrementing. Okay. So if the condition is true, then it will execute code, any program inside this for loop. So this is the difference. Okay. You put everything on the for condition. And then we also have another looping, but this looping, as you can see here, okay, the output can give 3 different results. Okay. So we call it break, continue, or go to. Okay. So it will start by statement block. So to achieve, it is achieved by assigning a label. To go to the jump definition by assigning a go to label. Okay. This one. It can jump to another program, to another subroutine, to another function, to another code, provided that condition is true. Okay. It can also repeat the statement, or it can also break out, okay, go out from this looping. So 3 output condition. And then we also have if-else statement. Okay. So if-else, if you can see from this diagram, okay, normally if we have 2 output, okay, whereby one output and then the another one is an alternative to the first one. Okay. So the first thing it will refer to the condition, check the condition first. If condition is true, execute the first block. Okay. If the condition is not true, do the alternative block. Okay. And then for switch case, this one when we have when we have different condition, but similar type. Okay. For example, it can be temperature. Temperature can be in the range of 0 to 10, 11 to 30, and so on. So we want this looping to respond at different conditions. So we use switch case. Okay. So for example, if for the first one condition is true, begin executing procedure number 1. Otherwise, you begin scanning the condition to find which one is true. And then the comparison, for switch case, we can use for more than one looping, but for else, it can give only either one. Okay. Even though to output, okay, the condition is either true or not true. Okay. So this is the program example by using the previously mentioned looping. So starting by looking by taking from the main subroutine. Okay, so we declare k first, k before the main subroutine. So k is the variable integer. So k will be global variable. It is declared outside the main, outside the subroutine main. So this means that we can use k anywhere in our subroutine also function. So we go by setting our control register for related microcontroller. Okay. And then this is for setting. Okay, so like so this is mentioned. Okay, we want to define what this code actually represent. So you can see here all I/O are configured as digital. So this means that these two code we want to configure our input/output port as digital, and then we reset port B, okay, by giving port B equal to hexadecimal of FF, which is 15 decimal. And then we set trace B, port B are configured as output. We set our port B as output, and then wait for 1 second, and then port B, we delete any initial value in port B, we reset port B value, and then we use for looping, okay, for looping, and then any value, any program we want to execute, we put it between for looping, and then we also have switch case. Okay. If switch port B is true, then you make port B, all bit from port B become true. If the condition is 0, if the value of port B is 15 or 1111 or true, all at bit is high, so you begin turning off every bit in port B. So it is if you connect the circuit using LED, so it is actually blinking. Okay, all port B will be turned on and also turned off, and then wait for 500 milliseconds, and then you do the rest okay, by checking the condition here. Okay. If the condition is true, repeat. Okay. Repeat for switch loop. Okay. If not true, okay, so what you can see here is the output. Okay. Start by blinking all on, and then after that turn off. Okay. And then if the condition here is not true, it will go out from this loop, and then it will put new value which is binary 0, 1, 0, 1, 0, 1. Okay. And then you go to continue looping. Okay. This one you want to invert the value of port B. The initial value is here, and then you invert. Okay. And then after that you wait for 200 milliseconds. So this is also blinking, but in an alternate direction. Okay. So starting with port B0, B1, B2, B0, B2, B4, B6. Okay. This one is even bit, and then after that turn off. Then you blink on the port side, port B, port number, okay, from port B. Okay, this one is the last one. Okay, so looking at our, okay, you have another 1 minute. Okay, so I think for this one, I need to stop here. So we will continue this one next week.